Okay, good morning everyone. Welcome to the synchronous session for MetE176. And today we'll be discussing about ternary diagrams now. Okay, so I hope you've already listened to the I don't know lesson about ternary diagrams in I've uploaded it in Oble pati doon sa Google Classroom, no. And by the way class, since okay ng Oble, balik tayo ulit sa Oble, no. Tapos, I'll be updating kung may time ako yung Google Classroom din just in case, mas gusto nyo dun din. Pero primarily dun tayo sa Uble, magkakaroon ng ano 'no, updates. Okay. So, let's talk about ternary diagrams 'no. And, I'll show you two techniques ngayon, yung phase analysis pati yung cooling curve analysis. So, if you've listened to the podcast, you'll dapat alam nyo na pagka cooling curve analysis, ang gagamitin natin is contour plots. And pag phase analysis, ang gagamitin natin is yung mga isothermal cuts, no? Okay? By the way, naririnig naman ako, no?
Yes po.
Okay. Thank you, Kervin. Okay, so siguro just a recap, no, kung paano ibabasahin ang ternary diagram. So, sabi natin na ternary diagrams is plotted on the Gibbs triangle, no, or it's an equilateral triangle. And sa Gibbs triangle natin, we have three corners, and the three corners or three vertices represent the 100% composition of a particular component, no. So since there are three components in a ternary diagram, then we have three vertices as well, no. So we have in this particular na diagram, nandito si A sa taas, dito si B, and then dito si C. So the way we read it is, again, pagka nasa vertex ka, you are at 100% composition. Tapos pag nasa opposite end ka, opposite edge ka ng vertex na yun, then you have 0% composition. And if you draw parallel lines, then you can create a scale, no? A linear scale for which there is increasing o increasing percent composition of a particular component. So in this case, since A nandito, then the baseline becomes your 0% A. And if you draw parallel lines to that baseline, then you can create a linear scale, no? From 0, 20, 40, 60, 80, etc. Tapos similarly, kung nandito ka sa bottom left, that's your B component. Therefore, yung right edge natin ang 0% B. So do-draw lang natin linearly din yung scale, no? So if you combine all that, you'll have something that looks like this, no? So siguro ang mahirap dito sa pag-read ng ano, no, sa pag-read ng atong ternary diagram is yung mga numbers sa gilid, no? Kasi minsan nalilito tayo kung kaninong scale yung nasa gilid. Okay? So for example, if etong A, dapat ang 0% A ay nandito, tama? Pero there are two sets of numbers dito sa baba at ah, dito sa left side. So minsan kunwari ang gagawin ko is A, so mag-measure ako from kunwari ito yung mini-measure ko, no. So this is 100% A, therefore magsisimula ako magbilang dito sa 0% dito sa baseline, no. So pwedeng gagawin ko is 0, 20, tapos eto, which is around 30%. Pero minsan magkakamali ako, sabi ko eto, dito, tapos dito, tapos dito ako nagbasa, no. So parang naisip ko, okey, somewhere around 70 siya. So 'yan yung mga cases wherein nagkakamali yung mga estudyante, 'no, kung yung reading the wrong line. So just be mindful, 'no, just kasi ito namang placement ng mga ano na 'to, scale na 'to is arbitrary, no, kasi I could have very well placed the XB scale dito sa ano, dito sa sa left side, tapos etong XA scale dito sa bottom edge. It's arbitrary in nature, no, wala namang meaning 'yan. So kasi if you draw a parallel line, then it still will serve its purpose, no. So eto, para lang may guide tayo kung ano yung exact numbers, pero kailangan ang pinaka-concept pa rin na babalikan natin is that yung kung ano yung opposite edge of the vertex, dun tayo magsisimula mag-measure. So dito ang gagawin ko is, since A nandito, opposite edge, this is 0, and I know that every mark is 20%, and therefore I crossed one mark and 1.5 mark. So meaning that's 30%. Okay, similarly, 'pag B component naman magsisimula ako from this baseline. So that's hindi ako aabot sa 20% which is this line. Tapos alam ko in between siya sa or 3/4 siya of the way. So 3/4 ng 20% is 15%. Okay? So that's why I arrive at 15% na composition. Ito 15%. Tapos you only need 2 no kasi again pagka sa ternary similar sa kung kunwari sa binary 'di ba pag binary kailangan lang natin ng isang component kasi yung other component will become an independent variable 'no. And I've discussed this in some detail dun sa podcast 'no. So dito naman, pagka ternary, 'pag na-define mo yung two components, yung last component will be an independent variable 'no. So, in this case, itong 55 susunod na lang siya kung ano yung balance man. Okay, so if I define 30 and 55, then itong 15 susunod na lang. Okay, so we only need 2 'no, pero if you want to be, kumbaga kung gusto niyo ma-double check maganda na rin na kunin niyo yung tatlo 'no. So, for example ito 30, 15 tapos try ko mag-measure from here 20, 40 tapos in 3/4 of the way 'no. So, ito yung kalahati ta's ito yung kalahati ng kalahati. So, that's 3/4 of the way from 40 to 60 is 55. So, that's one way para ma-double check niyo 'no, kung tama yung values niyo, just read all of the three components para at least may way kayo na ma-double check if tama ba. Okay. So, let's try reading etong N 'no, and M and I've already listed the ano 'no, kung ano yung, value niya. Pero kung ita-try natin i-read 'to, so start tayo with point N. Tapos sa point N, if, kunin natin yung A component, this is, the baseline A. The baseline opposite to or the edge opposite to point A. Therefore, 'pag nagbilang ako, magsisimula ako dito sa edge na 'to. So that's dito, ta's hindi siya umabot sa 10% which is yung gitna 'no. Hindi siya umabot dito, tapos parang slightly below lang siya ng 10%. So I'm estimating na ano 'no, that it is around, 8%. Pero what you can do is, I've linked a software class 'no, and let me just copy this. Tapos save natin. New, okay. Tapos pakita ko sa inyo kung paano gumamit nung ImageJ software na sinasabi ko last time. Okay. So, let me ano 'no, change the ano, transition. Hide natin 'tong floating meeting controls. Okay. So, ImageJ software looks something like this 'no. Ito yung makikita nyo dapat. If you open it's actually just a zip file 'no, tapos, mapupunta siya sa parang ganito. So, I saved it in my D drive tapos meron siyang image.exe and meron bang download, nag-attempt mag-download? It's very useful class 'no, sobrang dami niyang application lalo na 'pag physical metallurgy yung track niyo or material science. Sobrang dami niyang puwedeng gawin. So, kunwari puwede siyang tumingin ng microstructures, yung mga ginagawa natin dati sa MetE12 ba yun or MetE13 yung parang ano tayo line intercept method. Yun kayang-kaya ni ImageJ yun. Pati yung area, yung magme-measure tayo ng area of the different na phases, kaya din niyang i-measure 'no or at least i-estimate yung mga measurements. So, I highly encourage you guys as future metallurgical engineers 'no to download this software and, try to tinker with it 'no. Okay. And siguro ang interesting na ano 'no, kahit sa thesis ko, sa master's thesis ko ginamit ko 'tong image eh 'no. Sobrang, laking portion ng thesis ko is attributed to the use of the image software. So, meron bang nakapag-download? Just a quick survey 'no, yes or no sa Zoom? No. 'Yun si JV na-try mo. Good job JV. So, ang karamihan hindi nag-ano 'no, ta's hindi nagre-reply yung iba. Pero at least merong isa na nag-try. So, JV, question lang, kumusta yung interface? Nakakalito ba? Diyan ka ba JV? Are you there? Parang baka napuputol si JB. Di pa na-open, na-download mo lang. So, ang issue lang siguro dito sa image J 'no, is, ah, hindi friendly yung interface niyo, medyo hindi siya intuitive. So, ah, for now ang ituturo ko lang sa inyo is, ah, ang ituturo ko lang muna is ano, kung paano mag-measure ng distances 'no. So, kumbaga linear distances muna. So, hindi ko muna ituturo yung mga advanced like yung thresholding, yung pag-measure ng mga areas, hindi muna, linear lang muna yung gagawin natin. Okay, so, gawin natin is, if nakabukas na 'tong image J, so puwede niyong i-drag yung image na gusto niyong i-analyze or puwede ring, gamitin niyo lang 'to, go to file, open, tapos, punta tayo sa eto muna 'no. So, buksan natin 'to. So, if ever, kunwari eto, gusto natin i-measure si N, then we want to create a ano 'no, parang in a way, ang gusto kasi natin is linear na scale from, this point to this point kasi alam naman natin na 20% 'to 'no. So gagawin lang natin is, kuha tayo ng line tapos, let me just ano 'no, okey. So, kuha tayo ng line, click natin analyze, tapos measure tayo. So parang ganyan. So puwede natin burahin yung first measurement 'to kasi hindi naman 'yan importante and hindi pa naka-setup yung ano ko kasi nagamit ko 'to dati, area yung mine-measure ko no'n. So, baguhin natin kasi since, length lang naman ang gusto natin, gawin natin is analyze, set measurements. Tapos ang gagawin natin instead of area, kuha tayo ng, um, line 'no, line distance. Wait lang, sorry. Check ko nga muna, ha. Meron naman palang length, so okey lang. So, baguhin ko lang yung ano, nakikita niyo ba yung yellow? Medyo hindi malinaw yung yellow 'no. So, let me remove ko muna 'to 'no. Tapos gawin natin is, image overlay, let me just ano 'no, ulit image overlay and remove natin, remove overlay. Bakit ang dami kong na-create? Naka-old version pala ako, hindi ko pala na-update 'to. Baka ito yung version na hindi niya kayang mag-ano 'no, clear ng ano, mga overlays. Okey, ulitin na lang natin. Pero sa newer version kaya niya mag-delete ng overlays 'no? Dito mukhang hindi kayo puwedeng magkamali. Nasa ano kasi ako, what version is this? 1.52, hindi nga siya updated. I-update ko na lang 'to. Anyway, so, ang gagawin natin is, baguhin lang natin yung color ng overlay natin. Wait, dito ata yun. Option, colors, hmm, yung kita. Let's do magenta na lang, okey. Okey, mas kita siguro, hopefully mas kita 'yan 'no. So, ang gawin natin is, buksan natin, so nakabukas na yung ano natin 'no, itong measurements. So, puwedeng gawin natin is we draw a line and we make a parallel line 'no, okey. Tapos measure natin. So, that's 100 and this is in pixels 'no. Pero puwede rin kung gusto niyo, puwede niyo i-calibrate 'to, pero for our case hindi naman necessary na i-calibrate natin 'no, kasi ano naman 'to, we are just wanting to know relative weights naman yung usual mine-measure natin 'no. So, ito, okey na sa atin 'to. So, adjust ko 'to. So, yung first na ginawa ko na measurement, eto na siya. So, ang shortcut key is you press the letter M tapos, magma-mark na siya dun sa or mag-a-add na siya ng measurement dito. So, if I move this from here to here, and I press M again, then it's 35/103. So, if I do a calculation, so calculator tayo. So that's 35 over 103, and let's multiply that by 20 kasi 'di ba 20 'yun. So I should get around 7%. So medyo off yung estimate ko 'no, na 8%, pero let's just say na mga 8 siguro 'yan. Baka bagay medyo 6 dapat siya 'no. So so 'yun yung isa sa mga ways na, puwede niyong, gamitin si ImageJ 'no. So, usually kasi dapat 'pag ginagawa niyo 'to is, naka-printed out yung ano mo, yung ternary diagram, tapos yung from the printed out ternary diagram, puwede niyo siyang puwede kayong gumamit ng ruler 'no, kasi, ta's i-measure niyo na lang yung mga line. So graphical talaga yung approach niya 'no. So medyo mahirap kasi na gumamit ka kasi dun sa if you remember, yung mga binary diagrams natin usually 'pag nagme-measure tayo ng distances, kinukuha lang natin yung, distances using yung XY coordinate system. Madali lang yun 'no, kasi naka-XY coordinate system lang kasi siya. So yung temperature being the Y, tapos composition being the X. So readily makaka-measure ka ng distances between them. The problem with here is hindi kasi 'to XY na coordinate system 'no. So parang ternary siya na coordinate system or triangular coordinate system, and medyo magkaiba yung math na ginagamit para mag-measure ng distance with this kind of system 'no. So you can research about it. Puwede niyong if you're not comfortable with the graphical approach, puwede naman i-research niyo how to measure distances, using, a triangular na diagram 'no. Hindi ko alam kung anong tawag sa ano yung proper mathematical term para sa, ganitong ano 'no, plotting system. So, try niyo na lang i-research 'no, and siguro I'll research, as well 'no, and mag-send ako ng mga, readings para kung gusto niyo yung gano'ng approach 'no, as opposed to yung graphical approach. Pero I think for us, for this course, think ko mas okay talaga na mag-graphical approach na lang tayo, okay. So that's, 6.7% 'no, so 7%, and pero dun sa ano slides ay, sa handouts natin 8% yung estimate ko kasi medyo in-eyeball ko lang 'to 'no, parang ang estimate ko kasi is this is somewhere, in between 10 pero not quite 10, so parang gano'n yung estimate ko. Okay, so, then we need another value 'no, so let's say try naman natin mag-measure yung B component. So, if B component naman mini-measure natin, so let's draw, o puwede rin mag-start tayo ng another ano 'no. So from B, we are measuring, this is our 100% B, therefore we measure from this side, tama? So eto, dito medyo mahirap 'no, kasi kailangan niyo mag-draw ng parallel line. So if I measure this one and I press M again, so that's 131, or 132 pixels. Tapos measure ako hanggang dito siguro. Okay, so I'm measuring from here kasi etong 60% na 'to, ito yung, may scale ako 'no. So if I do that, I press measure again, so that's 198. So if I do the calculation, then I can take 132 divided by 198 multiplied by 60, tama? So that's around 40, saktong 40 'no? Bakit sakto siyang 40? Sorry. Na-misread ko yung, ito yung mga cases na sinasabi ko 'no, na-misread ko. Dapat, this is 20, this is 40. So dapat, times 40 dapat siya. So, 'di ba by 60 ulit natin ta's times, anong sabi ko, 40. So 26.67. So around 27 dapat siya, and medyo accurate naman yung ginawa ko nung in-eyeball ko lang siya. So that's 27%. Then puwede nang, i-balance ko na lang yung isa 'no, or puwede ring i-measure ko just to be sure. Let's measure it 'no. That's, from C. So let's measure it from C. This is the baseline of C. So what I'll do is, nasaan siya, end component diyan, so I'll draw a vertical line. And, dito sa class, if you press shift, then you are sure that you create a vertical line 'no. So puwede ring if you press shift, you are sure to create a, horizontal line. Tapos meron din siyang, 45 degree. So nagsa-snap siya kumbaga. So, kung gumagamit kayo ng ganito, press shift if you know you are doing a, horizontal, vertical, or a 45 degree line. Okay, so dito, from here measure tayo. Gawin natin is ano siya, vertical line, and I'm pressing shift para ma-ensure 'yun. So, if I press M again, that's 283 pixels. Tapos gawin natin hanggang dito, 80. Okay? So, press M again. So, that's 283 over 35. So, I can do 283 divided by 335. And that should give me 0.844. Multiply it by 80. And this will give me 67.58. So, ito, binalance ko lang kasi, so 65. So, kung binago natin 'to, which is, 'di ba nung nag-readjust tayo ginawa nating around 7%. So, nagme-make sense na 'to na nag-67 siya, okey? So yun yung mga ways na puwede niyong gamitin itong si ano 'no, si ImageJ. And let's, use ImageJ again to, do face analysis 'no. Okay, so that's, basic lang, plotting lang 'to 'no. Now let's do, image analysis for face analysis naman tayo. So, for this, try natin yung examples na binigay ko sa ano 'no. So these are examples, from real world na ano 'no, or empirical data 'to. So if you notice, kung familiar kayo sa symbol na 'to, you should be able to notice na ito ay from thermocalc 'to 'no. So familiar ba kayo sa thermocalc? You should be doing it in or nagawa 17.1 pa lang kayo 'no, tama? So for those na nag-17.1, baka na-encounter niyo na 'to 'no. Hindi ko alam kung what part of the SEM 'to siya ginagawa, baka later on pa sa phase diagrams construction. Pero, meron kasing, tool na ginagamit tayo 'no, yung thermocalc. So thermocalc is parang a computational thermodynamic software that is very, versatile 'no. So one of the functions it can do uh based on a database, puwede kayong mag-create ng mga ternary diagrams and maglalagay lang kayo ng parameters 'no. A similar na program to thermocalc is yung pandat na software 'no. So puwedeng either of those. So ito nakuha 'to from thermocalc, and try natin mag-face analysis dito 'no. Okay. So let's, open and close ko lang 'to, ta's bukas then tapos, I can delete my data 'no, itong analysis. Pero puwede niyo i-save actually yung data 'no, and wala pala tayong control Z dito sa version na 'to. Ang alam ko dun sa latest version may control Z na siya, but I could be wrong 'no. So ito, puwede actually i-save as mo yung, data mo, tapos puwede siya naka-save as, CSV 'no. Meron akong Ancient Aliens. Anyway. So, eto, buksan natin yung ternary diagram na yun, ta's naka-save na sa desktop ko. So, buksan lang natin siya, eto siya. So, eto yung ternary phase diagram natin. Tapos, what we'll notice is meron tayong several na ano 'no, and na-discuss ko na rin 'to um sa podcast. So, i ma mag-skim through na lang ako dito 'no. So, meron tayong again indicator natin pagka merong mga tie lines na ganito, itong green na 'to, mga tie lines that are connecting, two single phase regions. Ibig sabihin nun ay ano siya 'no, that is a, two-phase na region. So, ito ang AG plus TI, 2CU. So, this is a ternary system of, copper, silver, and titanium 'no. Okay. So, meron tayong two-phase region, eto at eto. Eto two-phase 'to, two-phase 'to, lahat ng may tie line is two-phase. So, therefore kung two-phase 'to, etong part na 'to, this is a, three-phase region 'no. So, which is, ano bang eto three-phase region, lahat ng mga, um, triangular na shape 'no. So, if you look at it, this is a single phase region. Ito yung vertex ng mga corner natin, eh. So, this is vertex ng triangle natin. Vertex, this is, this is for the AG, tapos eto, ang sabi is, this is for the TI2CU na line. So, kung nandito ka na side, it's TI2AG, pero dito banda, no, no. TI2AG ata is, this line 'no. Pero in any case, medyo complicated kasi itong phase diagram na 'to. Pero dito, Ti2Cu nandito. So dito, wala siyang single phase field 'no, parang, isang line lang siya na nagde-divide ng two portions na 'to. So ito, dito yung proportions kung saan nag-e-exist si Ti2Cu. Minsan ang tinatawag dito 'no is an isopleth. So isopleth is a line with constant, molar ratio 'no. So ito yung isopleth kung saan nag-e-exist si Ti2Cu. Tapos sa other vertex, this is Ti-Cu naman. Ti-Cu, which is this one. So ibig sabihin itong three-phase region na 'to consists of, the pure Ag, and it depends kung anong, form ng Ag 'no, and I think, wala namang sinabi, mukhang AG lang based on yung mga two-phase region 'no. So this is just AG plus, TICU plus Ti2Cu, itong three-phase field na 'to. And you can predict for almost all of the, other regions 'no. So ito ay isang liquid na region, so that's why itong tie line na 'to, which is connecting this single phase itong two-phase region na 'to that connects this single phase and this single phase right here is for the liquid, that's L, plus dun sa opposite end, that's Ti2Cu3, which is this one, Ti2Cu3. Again, this is a more complicated case naman, class 'no. Yung sa podcast, ang pinakita ko dun is, yung and dun sa handouts niyo, ang ginawa naman nating examples is for simpler na systems 'no, na clearly defined kung ano yung two-phase, three-phase, and single phase. Pero, in any case, eto naman kaya naman natin ma-identify pa rin 'no. So eto, this is if we were to, deduct kung ano 'tong two-phase region na 'to, again pagka may nakita kayong tie line, automatic, two-phase 'yun 'no. So may tie lines dito, therefore ito is, the liquid plus this is pure copper 'no, kasi ito yung, copper region, itong pure copper na dito, tapos ito yung ang pure titanium nandito banda, maliit lang yung region niya 'no, pero meron siyang secondary na allotrope of pure titanium, which is the beta phase. So kaya siya may beta dito. This is a phase of your titanium 'no, or, mostly titanium na ano composition. Ito na dito. Okay? So I hope that makes sense 'no? So eto, this should be liquid plus copper. Tapos eto, Thailand puwede rin i-ano natin, this is etong two-phase region na 'to should be copper plus TiCu4. Okay? Nagme-make sense ba 'yun? Questions about, reading? Kahit ano muna, eto simple lang muna ginagawa natin 'no? We are doing, parang determination of phases present. Medyo madali lang 'no? Kaya naman? May nag-no na, or kanina pa ba 'to? Kervin,
Kanina pa po yata. Opo,
ah,
kanina hindi ko pa naalis.
okey, okey, sige. So, pero so far okey naman, kaya naman?
Yes po, kaya naman.
Okay, good, good. Thank you, Kervin, for the feedback 'no. So, if at any point in the ano 'no, the discussion class na medyo nalito kayo, just raise your hand or, open your mics, tapos, puwede nating i-address agad 'no. Anyway, so yun yung determination of the phases, ta's try lang natin kunwari, kuha tayo ng random ano 'no, and kailangan ko palang wait lang, i-edit natin para meron tayong ano, oh, recent ternary. Lagay tayo ng, random na point 'no. Let's do one three-phase point and one two-phase para ano, anong maganda, anong medyo madali? Eto na lang, kuha tayo somewhere dito, brush tayo ng kulay pula, sige. Oh, ba't walang lumalabas? Fill is solid, outline is no outline. Try lang natin somewhere dito siguro. Ayan, diyan. Tapos try natin sa isang two-phase, hmm, yung medyo dito na lang, or kayo anong gusto niyong two-phase? Meron ba kayong preferred? Actually, parang mas madali ata kung ang ginawa nating three-phase or para lang mas ma-illustrate natin class, no? Is sige, dalawa na lang gagawin natin. Itong three-phase na 'to, tapos isang two-phase. Sige, ito na lang dito, two-phase na 'to. So, let's save that. Buksan lang natin siya ulit. Okay? So, meron na tayong mga points na of interest, no? So, try natin muna. If two-phase field, ang gagawin lang natin is just follow the tie lines, no? So, ang gagawin natin is, and the rules apply, no? Sa kung ano man yung rules na ginamit natin for the tie line, mag-a-apply din siya dito. So, doon sa sa example na binigay ko sa podcast is or doon sa handouts is no, conveniently nakalagay yung um, isang anong tawag dito, yung point natin along a particular tie line kaya madali lang mag-measure. So if I could show it, no, ito yung ginamit natin. Itong composition A, which is conveniently nakalocate siya sa isang tie line, no? So kaya medyo madali 'yon. Pero what if hindi siya nakalocate sa isang tie line? Kunwari ito, nandito siya. So gagawin lang naman natin is ifa-follow lang natin yung or i-interpolate lang natin kung ano yung expected line based on the adjacent na mga tie line. So, if that's the tie line or those are the two adjacent tie lines, then I'm estimating na nandito yung two ko. So, somewhere in between these two tie lines, no, existing tie lines. So, pwede siguro gawin ko parang ganyan. Okay? So, if I measure that, that is I pressed M. So, ito siya. Ito yung 121. So, 121 is the total length of the tie line. Okay? So, again, this is liquid plus copper na region. No? Kasi ito yung kinoconnect kasi niya itong single phase na to, which is the liquid phase, and itong single phase na to, which is the copper phase. So, if I were to get um, the composition of my or the amounts of phases in my mixture dito sa two-phase region na to, then I will just get the inverse lever rule, no? So, for example, if I want to get liquid, then I just readjust this, parang ganyan. Press M, measure. So, that's 49.351. So, 49.3 divided by 121.34 gives me 40%. So that's 0.406. So let's just say 41%. Therefore, itong particular na composition na to will be 41% liquid, tapos 41% liquid and ano yung nakuha ko? 41% liquid, and if you do the balance or pwede rin gawin nyo yung no, measure naman yung opposite side, that's around 59% na no. So 41 na liquid, 59% na copper. Okay? So that's how you do phase amounts. Tapos yung composition naman is similar dun sa no. Ang gagawin lang natin is we take this point. Etong kung yung ends ng tie lines natin, which is ito yung tie line natin, no. So yung end nito, itong end point na to at end point na to, kunin natin siya. Tapos i-measure lang natin siya using yung plotting techniques kanina. So dito, wala kasing scale, no. So meron naman palang scale itong 100, may 0 to 100 dito, tapos may 80 to 90 dito. So try natin. So if we are measuring from here, and since walang naka-overlay, no, medyo mahirap to, pero I think we can manage, no. So if I do somewhere in between dito yun, no, so yung end ng tie line natin. So if I do a parallel line dito, so I should get the TI composition naman. Tama? So wait lang, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So tig 10% dito. Dito sa right edge na to, although hindi niya nilagay yung scale, no, tig 10% itong different markers na to. Okay? Okay, so eto, if I do this and measure, that's 37.047 pixels. So if I measure again dito from here to here, oh, measure, and that's 59.7070. So let's just do 58. So that's 37 divided by 58. you get 63% or 64%. No, sorry. I-multiply pa natin by 10, no? Kasi 10% kasi yung buong length na yun. Itong buong length na to is 10%. So, multiply natin by 10%. So, that gives us 6.37. So, from here, so itong point na to is around 6.4%. 6.4% ng titanium. Again, since nag-measure tayo from dito sa baseline na to, no? So, that's 6.4% titanium. Tapos, pwede nyong ah, let's do it again, no? Pwede ring gawin natin is, mas maganda pala before natin pinasok dito sa ano, no? Sa anong tawag dito? Dito sa image J, dapat nag-mark na tayo ng mga endlines, yung endpoints ng tilelines na gagamitin natin, no? Para mas madali siya. And I think I'll probably do that, no? Para mas madali siya. So, if I open kahit simpleng software lang, no? I can use Paint lang. Paint is simple enough. Tapos buksan natin ulit yun, ternary. Tapos, dapat minark natin 'to, 'no? No, na eto yung tile line. Masyadong makapal. Let's do that. Tapos change color. So, puwede sigurong ganyan, 'no? Mark natin 'yan. Tapos i-mark na rin natin yung three-phase region na gagamitin natin. So, itong three-phase region na 'to, and for three-phase region, instead of, doing inverse lever rule, ang ginagawa natin is yung gravity rule. Okay, so the way we do gravity rule, and I hope you already know this, no, is we take the vertex, let it pass through the composition of interest, tapos i-allow natin na mag-intersect siya doon sa opposite baseline. So we do that 3 times for all three faces present in the three-phase region, and we get parang kumbaga parang mini levers, no? So inside this three-phase region, meron tayong na-create na three tie lines, kumbaga parang quote-unquote tie lines, no? So this is one tie line, this is another, and this is another. And we'll use what we call as the gravity rule, or sometimes it's the center of gravity rule yung tawag, uh, to get the relative amounts of the different phases. And later ipapakita ko din sa inyo kung paano kunin yung yung bukod sa relative amounts, yung composition of each of those phases. Okay? So, just to clarify, class, no, kasi I'll be using these terms a lot. Um, and I've also used these terms a lot before, no, dun sa binary diagram. Pag sinabi nating amounts, we mean the percentages of each of the phases that are present in a mixture, no? So kunwari nasa two-phase region tayo, ito. So meaning mixture siya of the liquid phase and the copper na phase. So pag sinabing phase amounts, I mean ilang percentage dun sa mixture na yon is copper at ilang percentage ay liquid. Pagka sinabi namang phase compositions, ibig sabihin nun, ilang percentage ng particular phase ay composed of a particular component. So for example, ito copper, let's just say itong dito na, no, itong liquid na to. So ilang percentage sa liquid na to is Ag, ilang percent ay copper, ilang percent ay titanium. Okay, so I hope that clarifies the terminologies, no? Yung difference between yung pag sinabi natin phase amounts or phase compositions. Pag another term for phase amounts is phase fractions, no? Minsan ginagamit din 'yon. So pag sinabing what are the phase fractions, that means the same thing as yung phase amounts, no? Okay? And again, different siya from phase composition. So let's save this file, no? Tapos buksan ulit natin siya using image.j. Open using image.j. So meron na tayong mga convenient points, no, para mas madaling mag-work on. So, na-determine natin yung copper natin is yung copper phase, ito. And I'm not quite sure kung ano yung kung anong tawag dito, Greek letter ang ginagamit. But let's just say alpha copper na lang siguro, no. Uh, Sige, copper na lang para to be more accurate, no? So, this is the copper phase, which again is baka lang kasi malito kayo pag sinabi kong copper phase. This is different from your copper from your copper composition or copper component. So sige, mas okay nga na sabihin ko na lang alpha copper 'to 'no. So ito is alpha copper. Usually naman kung ano yung pinaka-stable siya yung magiging alpha phase. So this is your alpha copper, therefore ito is alpha silver. Yung nandito yung maliit na portion na 'to, this is the alpha titanium, and therefore itong next na phase is the beta titanium. Okay? Malinaw ba 'yon? So, siguro baka since wala pa kayong masyadong experience on different types of systems, medyo nalilito pa kayo kung kung hindi explicitly stated 'no, kung ano yung ibig sabihin ng or ano yung, parang expected na Greek letters for, different different phases 'no. Pero usually class pagka, kung ano man yung pinaka-stable at room temperature, siya yung magiging alpha. So, notice how yung iron at room temperature alpha ferrite yung tawag natin sa kanya, tama? And then as we increase the temperature, nagiging beta siya, which is an obsolete phase now. Yung nakwento ko dati 'no, obsolete na si beta. Tapos next is si gamma phase, which is the austenite at elevated temperatures. Tapos next is pagka tumaas pa kayo ng temperature, darating kayo sa delta phase naman. Okay? So dito, we are fairly certain na itong first na region na 'to is the alpha copper, ito is alpha silver, and dito is alpha titanium. Okay? So para lang, malinaw tayo na this is a phase and not a component 'no. Okay? So, yung alpha copper natin contains 6.4% na na titanium, tapos puwedeng kuha tayo ng isa pa para lang malaman natin yung buong composition ng alpha copper natin 'no. So if we do another tile line, no, sorry, we do another measurement 'no. So I'm making this parallel to the horizontal plane. So eto, measure 36 pixels, tapos eto measure ko nandito, which is one parang grading 'no. So that is 117, and that's for 20%. So if I do the math, that's 36 over 117 gives me 0.3. Multiply that by 20, tama? Kasi 20 naman itong line na kinuha ko is the 20% line. So that's from 80 to 100. So this particular na scale is for 20%. If I do that, it's 6.15. Okay? So, ang nakuha natin kanina 6.15, and this is for 6.15. I'm measuring it from, where am I measuring it? From 0 to uh, AG 'no. So, ito is for AG. So, notice class na baka kasi magtaka kayo 'no, bakit ako nag-measure from the horizontal line at hindi ako nag-measure from hindi ba dapat sir nagme-measure tayo perpendicular from the baseline? So, 'di ba ang more accurate should be I'm measuring from this perpendicular line, tama? Which is true, mas accurate naman 'yun, pero note, again, this is an equilateral triangle class 'no. So every triangle every baseline ng triangle na maki-create nyo is, or every edge ng triangle na maki-create nyo are similar triangles. So yung proportions nila will remain the same. Okay? Nagme-make sense ba 'yun? So, siguro mas ma-illustrate ko kung nandito 'no. Kunwari ito, if I measure from here to here, yung proportion kunwari nasa gitna siya 'no. If I measure from here to here, I can do, kunwari nandito yung point natin, gitna. So, if I do measure from here, tapos kunin ko 'tong ano na 'to, length na 'to and length na 'to, which will give me around, 50% of this line, then I can get the percentage dito. But I can very well also do, and let me just open my annotating software na lang para mas ma-imagine niyo ng lalo. Okay? So, I'll just show kung bakit nagme-make sense yung yung ginawa ko. Usually Photoshop yung ginagamit ko class 'no para ano, kasi medyo sanay ako sa but you can do, other softwares naman 'no. Puwedeng Paint actually. Paint is good enough naman 'no. Okay? Copy natin, paste natin dito. Oop, bitin. Parating. Okay. So ito, kunwari class, if I do, kunwari ito yung point na of interest sa'kin 'no, ito. Now, if I do something like ito yung pinili kong tie line or parang hindi naman tie line, scale 'no. Kung itong ginamit yung scale, then I can measure from here to here, that's 50%. Tapos etong buong scale na 'to which is, 20%. So to 50% of 20 will give me 10. So kaya 10 to from dito. Pero puwede din naman na ang gawin ko is from here to here, tama? And that's still 50%. So and this is, 20 pa rin siya. Tapos if I do something like kunwari eto to dito, yung, perpendicular distance naman siya at from here to here, 50% pa rin siya kasi kumbaga yung proportions kasi ng similar triangles na 'to, remains the same 'no. So it doesn't, really matter kung ano yung pipiliin niyo na scale when you do yung image J analysis na ginagawa ko, hindi it, doesn't really matter kung ano yung pinipili niyo. As long as pumipili kayo ng scale na may, measurable yung distances niya or kaya niyong makuha yung relative ratios ng distances from whichever particular point you're measuring. Okay? Okay, so I hope that makes sense and close na natin 'to. So, okay lang na yung ginagawa ko kanina 'no na, ang ginawa ko is nung nag-measure ako sa image J ko, I did, dito sa baseline na 'to. Kasi parang mas madali kasi sa'kin na kumuha sa baseline kasi meron na akong gradings dito ta's ang gawin ko na lang is kunin yung, parang parallel to that baseline. So, okay lang yun. Saglit lang class, 5 minutes. Puwede tayong mag-break siguro 5 minutes? Okay, thank you. Ah, pahinga muna kayo or water break. 5 minutes lang. Okay, I'm back. 5 minutes na ba tayo? Siguro 5 minutes na 'yun. Nandiyan pa ba kayo class? Hello, hello? Pa-yes na lang kung nandito na lahat para alam ko kung puwede tayong mag-proceed ulit. Isa lang nag-yes. Baka on break pa lang. Mm. Isa lang nandito, si Lloyd lang. Dito na rin si Larnie, okey. Kailangan ko ba mag-roll call? Ilang minutes na nakalipas? Hindi ko kasi na ano 'no, nag-order lang kasi kami, sorry class 'no. Nandito rin si Kervin, dito rin si JV. Zarina, nandito ka ba? Si Alcantara, si Naya 'to 'di ba? Naya, are you here? Kervin is here. Excel, dito. Okay, good, good. And sino yung si Naya na lang. Is Naya here? Isa lang naman na kulang. Pwede sigurong start na tayo tapos, since recorded naman baka puwedeng balikan na lang ni Naya 'no. Okay, so let's ano ulit 'no, continue the lesson. So let's pick up where we left off 'no. So, sabi natin, puwede tayong gumamit ng mga baselines para, or yung mga existing scales para makuha yung mga, percentages no. So, again, medyo mahirap lang 'tong ano 'no, yung particular na diagram na 'to kasi walang naka-overlay na parang na scales 'no. Pero kung may naka-overlay na scales dito, mas madali sana siya. So, something like kunwari ito, may mga naka-overlay na scales 'no. So, ang issue naman sa naka-overlay na scales is, um, medyo confusing siya 'no, kasi kumbaga nag-i-intercept siya ng different mga tie lines. So, lalo na pagka itong overlaid na scale na 'to is ano 'no, anong tawag dito, um, same color lang sila or same opacity, medyo mahirap makita yung different na ano 'no. So, it's a balance 'no. So, dito, one thing you can do is kunwari lang meron kayong nito, puwede kayong actually kuha lang kayo ng ano, um blank na ternary, plot or Gibbs triangle. Tapos yung blank na ternary plot na yun puwede niyong i-overlay dito. Tapos 'pag na-overlay niyo siya, puwede na kayong kumbaga kahit lower opacity lang tapos i-overlay niyo siya diyan para at least mas ma-imagine niyo yung ano 'no, yung parang points ng different na graphs natin. Okay. So, we have 30 minutes left. So, I think we can do kaya naman natin 'tong ano 'no, we can do one phase tapos cooling curve analysis tayo. So, dito yung three phase naman tayo. So, itong three phase region, so I can zoom in by just pressing control and scroll up 'no. So, I'll do that. Tapos, dito sa three phase region na 'to, to do the Gibbs phase rule, ang gagawin natin is we take, the measuring tool ulit. Tapos, kunin natin siya and just to have a clear slate 'no, or clean slate, i-ano ko 'to, burahin ko yung results para start ako dito. So, I can do something like that. Puwedeng mag-zoom in pa ako more para mas malinaw. So, take my first measurement. That is the entire tie line for this TICU4 na face. So, that is the length. Tapos if I want to get the ano, um, the inverse lever. So again, this is the ICU4, therefore yung inverse lever siya yung kumbaga phase amounts ditong ano na to ng particular phase na to. So if I take the measurement, so that's 11. So we do 11.8 divided by 42.7. So that's 27%. So 27% of my three phase, which is TiCu4, liquid, and alpha copper, is composed of 27% TiCu4. Okay? Next is try natin tong dito naman. This is for the alpha copper to no. So this is my alpha copper. So inverse lever muna tayo. Ito siya. Tapos measure din natin uh, yung full tie line length. So yan. So that's 19 over 44. So let's do 19 or 20 na natin. 20 over 45. We get 44%. Now from here, pwede na tayo mag-balance, no? So, yung kanina, 27 nga ba yun? Kanina is 27%, 44%. So that's 27 plus 44 minus 100 gives us 29%. So pwedeng i-balance na lang natin itong liquid, no? So the liquid should be around 29%. So that's how we do the the gravity rule for our three-phase region. Tapos para makuha yung compositions naman, again, composition is different from phase amounts, no? Para makuha yung compositions, kunin lang natin yung composition of each of the vertex, no? So kunwari ito, this vertex will signify the composition of the liquid phase. Itong vertex na to will signify the composition of the alpha copper. And ito, dito, this will signify the composition of the TiCu4 phase. Okay, so I'll no longer be showing that, no, kasi FICO naman, we've done many examples, no, in determining compositions na FICO mas kaya nyo nang gawin siya on your own, no. Okay? So before we proceed with cooling curve analysis, meron bang questions about dito sa how to do phase analysis for two-phase pati three-phase regions? Meron? Naka-mute ka ba, Kervin? Okay. Sabi, none po. Thanks, Kervin. How about the others? If you parang medyo nag-grasp nyo yung lesson, maybe you can click the yes na button. Yes or like para lang medyo mag-gauge ko, no, kung nakuha ba. Okay, yes. May isa nag-yes. How about the others? Medyo may muddy points ba? Larny, thank you Larny sa feedback. Hindi nagre-reply yung iba, no? Medyo baka AFK. So, would it be okay na mag-proceed tayo sa cooling curve analysis? Kung may further questions na lang kayo, you can email me na lang, class, no? Email me or message me if there are particular na Siguro po ang kailangan lang is ma-master yung app. Explore pa po konti. Okay, okay. That's a good suggestion. No? Kervin. Pwede sigurong I can upload. If I have time, no, pwedeng siguro mag-upload ako ng supplemental na video on the different ins and outs nung itong ImageJ software, no? Para at least ito na yung go-to software nyo when it comes to measuring different distances, no? Ganun na lang siguro gawin natin.
Thank
Or
you,
I can
sir.
send the mga resources, no, to help you with the etong ImageJ. Marami naman yan. Actually, in YouTube, sobrang daming tutorials, no, on ImageJ because, again, sobrang sobrang helpful niya, no, in multiple fields. Hindi lang yung mga biology students, mga masters, PhD students, almost all of them use ImageJ, no. Ito yung go-to software niya. Okay? So, let's proceed, no. Cooling curve analysis naman tayo. So, let's do cooling curve analysis. And again, pag cooling curve analysis, instead of using isothermal cuts, ang gagawin natin is a contour plot. So, a contour plot is parang gusto natin ma-measure yung or gusto natin ma-imagine yung isang surface, ang isang 3D surface and translate that into a 2D, into the 2D space. So for example, ito, if nakikita nyo to, ito mga parang na to, no? And the way I see it is para siyang mga no, yung sa Sydney Opera House, kung familiar kayo doon. If you look at the roofs of the Sydney Opera House, medyo parang gano'n, parabolic pa tawag doon. Parang gano'n na shape, no? So yun yung na-imagine ko dito. So again, eto siya, these are just yung mga eutectic surfaces yung tawag natin dito, no. So for simplicity's sake, ang gagawin natin is eutectic surfaces muna tayo, and meaning yung if you look at the different yung kumbaga face ng parang triangular prism na to for the 3D solid, if you look at the face, that will just give you the binary eutectic ng component. For example, this face will give you A and C. Tapos yung kabilang face naman, it's A and B. Kabilang face is B and C. So if you know the binary eutectic na graphs, and usually pag binary eutectic medyo simple lang naman yung no. So Let me just open. So para lang mas ma-imagine nyo class, no? Ah, I'm hoping na lahat kayo familiar na kung ano itsura ng isang binary eutectic na phase diagram, no? And kahit ano, no, you can draw it in your sleep siguro, ganong levels. So let's just do uh, see pa dito. So try lang natin. Yung binary eutectic usually ganito lang yung itsura niya, no? So we have meron tayong ano dito, a single phase of the first solid, single phase of the another solid. Meron tayong eutectic na line. Meron tayong liquidus curve dito sa first part and another liquidus curve dito sa other side. Tapos encompass siya sa isang uh, phase diagram na ganyan, no? And usually, ito, nagmi-meet to dito. So, ito, nagsisignify ng parang melting point ng pure component, whatever pure component this is. And ito naman, melting point ng pure component dito na side. So, if it's, kunwari, uh, lead and tin, so kunwari 10 to, ito yung lead. Then dito sa side na to, this is the melting point of lead. This is the melting point of tin. Tapos ito yung magiging eutectic temperature, eutectic point ng binary system na to. Okay? So try to imagine ito, no? Ito mga binary eutectics na to, nilagay natin siya dito sa each of the different na parang face I mean FACE, no? Face of the ternary eutectic diagram. So ang ternary eutectic diagram kasi pag ginawa nating 3D para siyang ano, no, triangular prism siya. So ito siya, tapos kung i-connect nyo yung different na ano na faces na yon, makakapag-produce kayo ng parang 3D surface, no? And this is your eutectic na liquidus surface. So liquidus, again, liquidus, pag sinabing liquidus, anything above it uh, will be 100% liquid na. So ito, 100% liquid yung nasa taas. So ito po din 100% liquid yung nasa taas. Okay? So yun yung imagination natin, no, pag when we talk about liquidous surface. So mga importante dito is ito yung liquidous surface, wherever they meet, yun yung eutectic trough ang tawag doon. Tapos ito, eutectic trough din to. This is also eutectic trough. So all three eutectic troughs will lead to the ternary eutectic point, which is the lowest point ng surface na to for this particular uh, ternary diagram. Okay, so if you look at it from the top view, pwede actually makaproduce kayo ng 2D na diagram, no? And the way we imagine the surface is using yung mga isotherms, no? So these are isotherms or contour lines which signify equal na temperature. So kahit naka 2D siya, parang nai-imagine pa rin natin yung itsura nung parang yung parang ano na yun, no? Mga surfaces na yun. So kunwari, kita ko na ito going down dyan, tapos ito yung trough na meet, nag-intersect sila. Tapos going down, pwede rin siya mag-meet dun sa ternary eutectic natin. Okay? So, eto medyo ano naman, no, na discuss in great detail naman to sa uh, sa sa podcast natin. So, hindi na ako gagawa ng examples para dito sa simple na ternary eutectic, no. Ang gagawin ko na example is yung etong more complicated case naman, which is etong ganito, no? So this is a case wherein we have a ang tawag dito is congruent melting, no? So congruent melting is just means na meron kang liquid that solidifies or crystallizes into a solid of the same composition as the liquid. So this is signified by this point, no? So kunwari ito. So ang yung liquid na to, nag-solidify siya into this particular na solid phase, which is labeled here as W, no? So from liquid to W, consistent yung composition niya, no? So kung kukunin mo yung composition ng W, then it's X% of, or it's N% of a particular component X, tas N% of a particular component Y, no? So in this case, parang inverse lever pa rin yung ginagamit, no? So kunwari itong W na to, it's this percent, itong portion na to, this percent X, and dito, it's this percent Y naman. Okay? So yun yung yung congruent melting, no. And the thing that makes this unique, yung congruent melting, is that parang dinidivide niya yung ternary diagram mo into two smaller triangles, no. And okay pa ba yung ano ko? Yung sound, or meron kayong naririnig na scratches? Hindi ko sigurado kasi. Okay pa naman?
Rinig po, sir, malinaw po.
Malinaw naman. Thank you, thank you. So, So, ang gagawin natin is parang wherever the congruent melting occurs, parang ini-split niya yung ano natin, no, yung ternary diagram into two smaller ternary diagrams. So, you can notice na dito, instead of having yung sa previous example natin, no, which is this one, instead of having one ternary eutectic point, para ang nangyari dito is you have two ternary eutectic points. So, meron kang ternary eutectic point dito, ternary eutectic point dito. Okay? Tapos, notice that since na-split to into two smaller ternary diagrams, yung eutectic surfaces din natin, meron siyang uh, parang six separate na ano, no, eutectic troughs. So, dati, tatlo lang yung eutectic trough leading towards a particular point dito. Pero dito, at this point na, meron kang tatlong eutectic troughs for this parang mini na ternary dito. Tapos meron ding uh, tatlong other eutectic troughs for this smaller na ternary diagram. So basically the calculations remains the same, no? Pero ang ano lang dito is you have to do or you have to follow whichever ternary diagram you are in. So for example, kung nandito yung composition mo, then you follow this ternary diagram. Kung nandito naman siya is kumbaga dito ka naman magma-manipulate. So there are ternary diagrams that look like this, no? Tapos meron din yung iba na sobrang complicated na multiple siya instead of two ternary diagrams, meron kayong parang three or four eutectic points, I mean. So meron kayong four. So yun, kailangan nyo lang, ang key lang doon is to follow the direction um, of the ano, no, of the lines. And I could probably show you, I don't know, so let me show you some examples of more complicated na ano. So buksan ko lang yung previous mga exams natin. Hydrodynamic. Previous exam 146 exams. Ito class, this is an example, no, of ano. Ito, this is an example of a parang an actual ternary diagram for a particular metal, no, or a particular ternary system, which is lead, tin, and bismuth, no. So this is a special type of parang solder din to. Okay, so if you notice na meron tayong different lines, so ito, you can see na meron tayong isang eutectic na point dito. Actually, hindi siya eutectic point, no? Ito lang yung, kasi wala kang congruent melting, so hindi ka nagkaroon ng parang separation into two smaller na ternary. So you can notice na merong directions yung ano, eutectic troughs natin. So again, when we're doing analysis, we always follow the direction of the eutectic trough. Kasi 'di ba, if hopefully you have looked at the podcast, no, if we try to draw a line from here to here, pag na-reach natin yung tectic trough, di ba parang nagpe-pivot kasi tayo, nagpe-pivot tayo along using the composition as the fulcrum, ipinipivot natin yung parang isoplet natin or yung tie line natin. Tapos we pivot the end of the tie line along the eutectic trough. So for example, pag nag-meet ako dito, so let me just show. So example kasi natin dito is meron tayong wala ito. 'Di ba ang ginawa natin is from here ito once na reach natin yung trough na to, nagmo-move tayo towards the eutectic point. Okay? And when we move towards the eutectic point, yung lever kumbaga natin or yung tie line kumbaga natin nagpi-pivot along this fulcrum X tapos nagmo-move siya itong point na 'to towards the eutectic point following this direction. Okay? So, consequently itong, ah, point N na 'to moving from dito siya 100% C siya dati, 'di ba? Nagmo-move siya towards dito. Okay? So, I've discussed that in the podcast also, just listen to it again para if you don't remember exactly kung paano siya. Pero the way so if we were to have something like this, kunwari na-meet mo composition tas na-meet mo 'tong trough na 'to. So the direction of this will tell you na dapat mag-move ka towards this point. Tapos once na-reach mo yung point na 'to, dito, move ka naman towards this point. Tapos after that, eto na yung final mo na destination, ternary. Okay? So, yun yung mga cases wherein kailangan mong pag-isipan 'no, kung anong path ba ite-take ko para, makuha ko yung final na, parang eutectic composition. Kasi again, continuously cooling 'to 'no, this is a cooling curve analysis. So, we are analyzing from the point na liquid siya papunta dun sa final na solid siya. And yung lowest point kasi is the ternary point, tama? So, yung final destination natin is etong point na 'to wherein yung final liquid natin reaches the eutectic point wherein it undergoes eutectic transformation. So, eutectic transformation being yung liquid transforming into two solid phases. Okay? So, balik tayo dun sa ano natin 'no, example natin. So, let's try etong congruent melting 'no, and let's just do op let's do this one. So, meron daw tayong composition A. So, yung first na gagawin natin is, and let me just copy this 'no. Composition A, tapos paint. Gawa tayo ng paint. Ulit tapos, I can probably do some lines 'no. Let me draw the first line dito, and I'll draw a second line papunta diyan. Kasi, this signifies yung mga end lines. So, pero along the way magkaka-produce tayo ng, different na ano pa na kumbaga, kaya natin ma-determine yung different na cooling points at any given, point in time 'no, during the cooling transformation. So, let me just save this and I'll say to cooling curve analysis, CCA. Okay, tapos buksan natin siya sa software natin, which is, close ko na 'to 'no. So, file, open, CCA, ito. Tapos, what I'll do is ito burahin ko na lang 'to. Okay? So, let's try this 'no. Ang gagawin natin is we are at point A, tapos, ah, the first thing we can determine, with this point A is yung, liquidus temperature ng particular composition na 'to 'no. So, notice again na eto kasi again this is a ano 'no, contour plot. So, meaning, etong mga lines na 'to signifies na meron tayong, equal na temperatures 'no. So, and we can know the curvature. So, etong point A na 'to, we are sure na magiging, liquid siya at a temperature equal to 1,000 degrees Celsius. So, just to recap siguro kung bakit siya gano'n, and again, this is explained in the podcast 'no, is, puwede natin tingnan yung diagram na 'to 'no. Where is that diagram? Hmm, parang hindi updated 'tong ginagamit ko. Anyway, sige wala siguro dito. Anyway, sige, sige. Kumbaga from here, if we move down from a particular composition, kunwari nandito siya, move down tayo sa particular composition, kung saan siya nag-intersect dito sa liquidus surface, yun yung, kumbaga liquidus temperature niya. Okay? So that's why dito sa case na 'to, eto sa case na 'to, we are seeing this from the top view 'no. So, we are moving from kunwari an elevated temperature, well beyond kunwari 1.5 tapos moving down tayo, liquid pa siya, liquid, liquid, liquid until it reaches etong point ng surface na 'to. And this point in the surface is, the 1,100 degrees Celsius. So, meaning at that point dun nagsisimula mag-crystallize yung solid natin. Okay? So if this point were moved, kunwari nandito yung point na 'to, kunwari somewhere dito si point 'no. Therefore, para makuha natin yung liquidus temperature, draw lang tayo ng, parang, interpolate lang tayo ng imaginary na isotherm 'no, para makuha yun. So kunwari kung nandito siya, that's around, 1,050 'no, tama? Kasi going down yung scale na 'to. So that's 1,050 kung nandito siya, okay? So magiging 1,050 yung liquidus temperature. Pero for this case, conveniently located siya at an isotherm 'no, so mas madali natin siyang ma-imagine. So we get this point. So it starts to cool, or it starts to produce the solid crystals at a temperature of 1,100 degrees Celsius. So kaya natin ma-determine yung relative amounts of the solid and the liquid phase as it progresses in the cooling stage, no. So kunwari lang, if we do something like this, kunwari, so hanggang, let's just say nag-cool down siya to 1,000 degrees Celsius, eto siya. Tama? So that means na nag-progress siya in a way na nag-cool na siya up to 1,000 degrees Celsius, tapos nag-produce na siya ng more crystals, no? Kasi as you go lower, nagpo-produce ka ng more crystals. How many crystals you produce can be determined through this isoplet, no? So itong isoplet na 'to is also a tie line. You can treat it as a tie line. Tapos pwede mo siyang i-measure yung amount of uh, the relative na amounts or relative fractions of the two phases, yung liquid at solid, no? So ito, i-measure ko siya yung entire length. Kunwari lang nag-cool tayo to 1,000 degrees Celsius, no? So at this point, etong lever na 'to, etong point na 'to, this is actually the liquid na point, no? Kasi if you imagine it, if you take the isoplethal na na cut na 'to and try to look at it, from, etong cut na 'to, no, try natin i-imagine yung magiging cross section niya. So the way I see it is, kunwari ito siya, itong 3D na 'to, itong nandito. Para tayo nag-cut ng kumuha tayo ng isopletal cut na pa-ganyan, tapos tingnan natin kung ano yung magiging contour ng, makikita natin sa kanya. So, medyo 11:30 na pala class 'no, pero mag-extend tayo konti. But if you have, other classes pa, then, you can go ahead na 'no. Pero those who don't have any classes and you want to stay, you're welcome to stay 'no. So kunwari lang ito class 'no, kunwari ganyan. So if we did the isopletal cut, we should get something that looks like this 'no. Parang kunwari ito yung isopletal cut natin, and we are doing an isopletal cut of this, image 'no, tama ito? Ito yung kukunin natin, isopletal cut na 'yan. So titingnan natin kung ano yung itsura ng cut na 'yon. We should get something that looks like parang ganito 'no. We should get something that looks like this. 'Yan yung isopletal cut natin. So if this were the composition A, ito yung composition A natin, and ito yung sa point na 1,000 degrees siya, tama, 1,000. So yung 1,100 'no, 1,100 degrees pala. This is 1,100 degrees, tapos bumaba tayo to 1,000 degrees. So ito. So ito na yung point na ina-analyze natin 'no, itong point na 'to, 1,000 degrees, 1,000. Then you'll notice na ito actually parang binary phase diagram lang siya, 'di ba? So if you look at it, ito from here to here, ito binary phase diagram 'to. Tapos ito actually, etong point na 'to at point na 'to, tie line lang 'to. And this is my liquid phase, tama? And this is my solid phase. So this is my liquid plus solid na region, tama? And if I complete the phase diagram, no, it should have something that looks like this. Kasi 'di ba, again, this is an ano, no, this is a, eutectic. So parang if I complete it, parang gano'n siguro yung itsura niya. So this is the solid phase, and let's just say solid, kunwari solid 1 kunwari 'to. This is solid 1, sorry, ano ba 'to? Solid 1, solid 1, parang ganyan. So 'di ba, ano siya, tie line siya. So this point here and point, sorry, hindi pala, hanggang dyan lang, no? Sorry. Hanggang dito lang dapat ang tie line natin. So, hanggang dito lang. Okay? So, this point represents our solid. Sige, since we are measuring the entire solid, no, pwedeng hanggang dito yung tie line natin. Okay lang yun. So, eto, since we are measuring, etong endpoint na to signifies the liquid phase, etong endpoint na to signifies the solid phase. So, in terms of dito sa ternary, eto siya. Etong yung endpoint na yun. Etong liquid na to, at eto yung endpoint ng solid. So, with that said, pwede tayong gumawa ng tie line, no? Ang inverse lever rule, eto, by inverse lever rule, we know that this lever signifies the phase amounts for the liquid and this lever signifies the phase amounts of the solid. Tama? So if we move down, ito i-move down natin, no? So let's move from here to here. So magiging ito yung entire length ng tie line. So yung liquid phase is taken by ano ko na ba to? Ito yung entire length. So if I take this one, this is the liquid phase. So if I do 97 divided by 131, then I have 74% liquid. So ngayon, from 100% liquid, nakapag-produce ako ng around 25% na solid. So at 1,000 degrees Celsius, meron akong 25% solid. Tapos pwede pang mag ano yun, no, at kunwari 900 degrees, then magbabago pa siya. I can get ganyan, no? So if I take the measurement, that's 157. And etong 97, hindi naman siya nagbabago, no? Kasi ito lang yung length na yun. Yung total lang yung nagbabago. Therefore, 97 over 157 gives me 61%. So, kumonti na yung ano natin, liquid. Naging 61% na lang siya, which means dumami yung solid, which is around mga 39 na yung solid natin. Okay? Or 38. 38 yung solid. Hanggang umabot siya dito sa trough na to. Umabot siya sa trough at around 800, no? Sakto, nag-match siya dito sa 800 degrees Celsius. So at 800 degrees Celsius, umabot na siya sa trough, and this is the point wherein mag-solidify na si X naman. Okay? So dito, at this point, from here to here, puro Z pa lang yung nagsusolidify. Okay? So whatever percent of the solid is, that is 100%. Kunwari, at this point, if we do the, ano no, I'll just do measurement 173. So that's 97 over 173 gives me 56% liquid. Again, yung mina-measure dito is the liquid tile, the liquid lever, no? So ibig sabihin, yung solid ko is around 44%. So 44% of the solid up to this point itong eutectic trough, 44 yung 44% na solid na yon is made out of 100% solid Z. Okay? So solid Z pa lang siya. Now, when it begins to solidify, magpo-follow na siya itong liquid eutectic trough na to. So kunwari, nag-solidify siya from 800 to 750 kunwari, which is at this, no? Kasi ito yung 800, meaning itong line na to is the 700 line or isotherm. So if that's 800, ito yung 750. Again, pag nag-move na tayo dito, yung fulcrum kasi natin will always be itong composition point A, no? Therefore, itong lever na to, magpipivot na siya along this fulcrum. So, magiging dito na siya. Okay? So, notice na parang siyang umikot, kumbaga, along this pivot point. Okay? Or the fulcrum. So, dito, you begin to see na once it drops to 750, from 100% Z, again, di ba, pag vertex, always 100% siya. So, from 100% Z, meron ka nang na-produce na other amounts, which is actually the X amount. Kasi di ba, ito ay edge, meaning binary composition to, yun nandito. Then you can use inverse lever rule ulit dito, no? So etong lever na to, sige, let's start, kunin muna natin yung solids and liquid percentages, no? So if and I'll just erase this all. So if I get this entire tie line here, ito yung entire tie line. So if I want to get the solid composition, then I just get this tie line, diba? So the solids now is, di ba nag-stop tayo at mga 40, 44 ata yung last natin. So ngayon, 90 over 150, that's 0.6. Nasa 60% solids na tayo. Okay? 60% solids. Pero yung 60% solid na yon of the mixture is not 100% Z. Merong percentage doon na X na. So how do we get the percentage of X? So we just do this, no? Ito yung marker natin. Gagawin lang natin is measure natin to. This is the composition of Z. Tama? Kasi inverse lever tayo eh. Kung ito yung 100% Z, therefore itong Z na to is the lever for the Z. So let's get that. Or pwede rin yung other side, no? It doesn't really matter. Pero ito yung una kong kinuha, that 334. And let's get the entire length of the tie line, which is 376. So we should get 334 divided by 376. That gives us 88% 88% Z. So, yung nakuha natin na 60% solids, the 60% solid is composed of 88% na Z. So, if you multiply that by 60, you get 53. So we have now three compositions na, no. So yung at this point, parang at this 750 degree na point, no, in time, meron kang 60% na solid, 40% liquid, at tapos yung 60% solid na yon is 88% na Z. So if I multiply 60% by 80%, that's 53. So meaning mga 7% yung liquid. So if I were to do a full phase analysis of the cooling curve at 750 degrees Celsius, dapat meron akong 53% Z, tapos um, 7%, what phase is this? 7% X, and 40% liquid. Okay? I hope that makes sense, no? So from ito yung 60% solids kasi to, solids, tapos 40% liquid. Pero pwede pa nating i-break down tong 60% na to into Z and X. So kung full breakdown yung ginawa natin or full phase analysis for this cooling curve, no, we should get etong 53Z, 7% X. Okay? So yun yung ano natin, no, way na pag-measure. So again, pwede naman ang ginawa ko dapat is I could have equally done is from here sa itong 750, no. Pwede naman ang kinuha kong lever is this lever, no. Pwede din naman ang kinumpute ko is this one. So if I do measure, tapos divide ko, that's 35 divided by 376. 35 divided by 376. I should get around ito 9% pero 7% yung na-calculate natin na balance, no, and that's just because of parang yung nag-estimate lang tayo, no, or yung medyo uh, hindi ko kasi na mark na maayos, no. So yun, mga konti lang naman ang error, no, na 9% 7%. So yun, pwedeng kuha lang kayo na isa tapos i-balance nyo na lang yung isa, no, para mas madali yung calculations nyo. Okay, so nandito tayo, 750 na tayo, tapos maba tayo hanggang eutectic point na. So punta tayo hanggang dito. Ito na yung parang last point kumbaga na meron tayong liquid. So if you get that tie line, and let me just remove everything, no. So that's 152. If you want to get the percent solids, pwedeng percent solids yung kunin natin o percent liquid. Kung percent solid, edi ito yung gagamitin natin. Kung percent liquid, edi ito yung gagamitin natin. So ito, percent liquid tayo. Try natin percent liquid. Tapos measure using M. So you'll get 41.7 divided by 152.2. So that's 28% na lang yung liquid natin. So since 28% na lang yung liquid, therefore mga 72% na yung solids, no? And again, pwede natin ma-compute yung amount ng solid. So we have at the eutectic temperature, temp, which is around, if I were to estimate, mga 650 siguro yan, no? Mga ganun, 650. Eutectic temp, 650 deg C. You have, ano yung number na yun? You have 28% liquid and 72% solid. Tapos again, pwede ko i-break down tong solid na to. So the solid is, if I use this point, pwedeng i-ganon ko siya. Tapos, this is the lever for my X component, no? So, if I press M, ito siya, 56. Nadoble ko. Ulit ko na lang isa. 56, tapos divide ko sa total length. M, that's 378. So, I have 57 divided by 379. I should get 17%. So this is 17% of the 72%. So I can just multiply this by 72, no? Oh, I can just multiply this by 72. Then I should get 12% na X. So ito, magiging 28% liquid. Tapos 12, sabihin natin 13% na X. Therefore, yung remaining is 72 minus 13. Yan ako na. 72 minus 13. That's 59. So yung remaining is 59% Z. Okay, so ito na yung final na point kung saan meron akong liquid, no? And anything below this, I will now produce 100% solid. Okay? Tapos etong 28% na to, then it will transform into eutectic na ano na siya. So yung 28% na to will now go to liquid plus solid 1 plus solid 2, whatever solids these are, no? Okay? So etong 28% yung mag-undergo nito. So, at any point in time, no, pwede akong mag-measure ng, kunwari, itong X, 13% X, ilang percent yung, hindi, kasi yung liquid actually yung pwede kong ma-measure, no? Kasi itong Z at X na to is always 100%, tama? Kasi yung end ng tie line nila, if you look at this, yung ends ng tie line nila is always yung etong vertex na to, which signifies 100% Z. Tapos ito din, 100% X. Therefore, lahat ng to will always be 100% Z, 100% X component. Pero itong liquid, pwede siya magbago, no? Kasi, kunwari, ito, from the start, nandito siya. You can do plotting, no? So that's around, sige, mag-estimate lang ako, no, class, no? So that's around, siguro, from here, if you do parallel lines, I'm saying, this is kung 52, mga 25% X. Tapos sa Z naman, it's around kung 52, 70, mga 70% Z kunwari, tapos yung balance will be the Y component. Okay? So again, using the techniques lang na natutunan natin doon sa basics, no? Pwede mo ma-measure yung liquid. Tapos from here, 'di ba, liquid nagsimula siya dito. Nung bumaba siya dito, edi nasa different point na tayo sa ternary plot. Then you can also get the percentage of composition naman to, no? Again, different from amounts. Composition naman to. You have percent %Z, percent %X, percent %W. Dito rin, percent %Z, percent %X, percent %W. Hanggang dito, no? At any point in time, kaya mong makuha yung percentage ng liquid natin in terms of its components, no? Okay? Or yung composition niya, kumbaga. Tapos yung X, Z, whichever solid phases are present, usually na-present sila in their 100% composition, no? Kasi if you look at this is end of the tie line, again, nasa vertex, therefore, ano siya. Okay? I hope that makes some sense, no? Usually itong cooling curve analysis mas useful siya sa mga ano class, no, yung mga cases na yung mga pyrometallurgical applications, no. For example, gusto mo malaman kung nagsa-slag analysis kayo, kung ano yung present na liquid, ano yung present na solid phases na, usually mas appropriate siya dun. But there are cases na nagagamit din siya sa physical metallurgy. Kunwari itong case na 'to, puwede mo ma-predict kung ano yung kunwari ano yung magiging melting point dapat ng isang ternary alloy. So that's one of the important applications, no? Kasi kunwari you are to design a process na you are casting kunwari itong ah, isang alloy na comprising of lead, tin and bismuth. Tapos gusto mo mag-design ng isang process wherein um, nagme-melt ka ng ganitong klaseng ternary alloy, then therefore, kailangan alam mo kung ano yung eutectic point para sure ka 100% solid na siya, 100% liquid na siya. Okay? Tapos kung kunwari gusto mo ma-analyze yung cooling curve niya, kung kunwari at 200 degrees Celsius biglang nagkakaproblema yung machine mo kunwari. So ano ba yung phases present kung bakit sa 200% medyo problematic siya. So pwede mong gawin yung phase analysis using cooling curve analysis, tapos pwede mo ma-analyze yun, no? So yun yung mga unique applications, no? And in fact, class, sa PBI, dati nagka-issue kami dito, no? Just to tell you ano, no, ay anecdote that highlights kung bakit useful yung mga ganitong diagrams in real world applications. Sa PBI kasi meron kaming process that deals with um the ang tawag dito, cooling of or casting of lead antimony alloys, no? So lead antimony plus other ano pa to components. So and in some cases, usually kasi kunwari natural reaction kasi ng mga tao is kunwari malapot siya tapos bumabara yung machine dahil malapot yung liquid melt mo. So, a natural tendency kasi ng mga tao is kunwari if you're not a metallurgical engineer, always ang natural instinct mo is baka mababa yung temperature, tama? Kasi parang kung gusto mo maging malabnaw yung isang melt, taasan mo temperature para mas matunaw siya, tama? Pero ang issue dun is, nung gumawa ako ng phase analysis, yung temperature way above the liquidus temperature. So sure ako liquid dapat siya, walang reason na magpo-produce ng solid. So turns out ang nangyari is dahil sobrang tinaasan nila yung temperature kasi again natural reaction is, sige taasan pa natin para matunaw. So ang nangyari is dahil sobrang taas ng temperature, bumilis yung kinetics ng reaction with oxygen. So with the air above it. So ang nangyari is mas nag-produce siya ng tinatawag na dross ang tawag, no. Dross is parang mga ano siya, no, mga kumbaga oxides ng liquid metal mo that floats above the liquid melt. So ang nangyari is sobrang daming dahil sobrang taas ng temperature, sobrang daming dross na produce, kaya yun yung nagpapalapot. So yun yung medyo unique na mga cases wherein sobrang nagagamit talaga natin yung metallurgical knowledge nating class, no, in actual na mga uh, processes in engineering. So yun lang, hopefully na-inspire kayo sa story ko, no, na maging physical metallurgist as opposed to yung maging go to the mining side or extractive side. Pero okay lang naman either way, whichever track you choose, okay lang naman 'yun, no. Pero konti lang kasi yung mga physical metallurgists, so I'm trying to inspire some of you to pursue that track, no. Okay? So okay ba tayo sa lesson for today? Sorry, nag-extend tayo ng quite some time, no? But hopefully, naging productive tayo today. Questions before we end the session? Okay ba? Okay, no, walang question. Thank you, Lloyd, for the ano. Okay, thank you, Kervin. Hopefully, marami tayong natutunan, no? Okay, si Naya to, no? Okay, Naya, thank you. Okay, I think we can end the session now, no? And hopefully marami kayong natutunan. And by the way, malapit na yung exam pala natin, class, no? After Holy Week, mag-exam na tayo sa first long exam natin. So we have 3 exams. Yun yung first of the 3 exams. Tapos, ang coverage natin is this phase equilibrium plus yung solidification of metals, which we'll be covering in the next 2 weeks, no? So, okay, yun lang. Thank you again for taking the time to come today. And for those who were not able to come today, you'll have this recording, no, para at least may pwede kayong tingnan, no. Okay, again, thank you. And I'll see you next week. And sana masarap yung ulam nyo, class.
Thank you, sir. Sana masarap din ulam nyo.
Thank you din.
Thank you, sir.
Thank you.